Continuing the teaching from last lesson, we were doing partial fractions. We started an example with a quadratic on the bottom, a quadratic factor. We decided to put a linear thing on the top. If we hadn't had a squared here, I'd just put b at the top. Because it was a squared there, we put bx plus c at the top. We had done our normal stuff, and we got down to this stage here, and we found what a was. We chose x to be 1 because it made this bracket here equal to 0. That disappeared. It meant all of that bit there disappeared, and I could find out what a is. And then I think I asked you, okay, what else shall we let x equal to make something disappear?
I.
Sorry?
I.
Oh, that's beyond us. We can't cope with that. That's the same thing. That's what Callum said. No, we could, yes, but we're not going to. We're not going to go to complex numbers, okay? So, is there any other value of x that will make stuff disappear? The answer is no, there isn't. Okay? So, what is a nice, simple number we could use?
1.
We've used that one already, but it's a good choice. What's another very nice, simple number? 0. Let x equal 0. Purely for convenience, because it makes the sums nice and easy to do. If I let x equal 0, this is where I'm carrying on from today, the left-hand side becomes 0 squared minus 3, which isn't too hard to work out. He's just hoping somebody will tell him the answer. 0 squared minus 3. Thank you. I was getting worried then. And on the right-hand side, if the x's are 0, that's just 1a. If the x's are 0, this bracket is just c. That bracket is just minus 1. Times those together, I get minus c. But I already know what a is. Last lesson I knew that a was minus 1. So if I just put that in there, if I shove things around, if I move the minus c onto the other side, it becomes a plus c. Move the minus 3 on the other side, it becomes a plus 3. Hey presto, I now know that c is equal to 2. Okay. So, from here, I just say, okay, you just bung another number in. 2 seems the next most straightforward, simple number. Doesn't really matter what we choose. We could have chosen 73.5. Been a bit crazy and stupid, but it would still have worked. Doesn't matter. Just keep things simple. When x is 2, Sean, what do we get on the left when x is 2? 1, yeah. 2 squared minus 3 is 1. And on the right, when x is 2, that bracket, Sean, is worth... yeah, 5a, okay. When x is 2, over here, this bracket is going to be 2b plus c. And when x is 2, that bracket's just going to be 1. So I won't bother writing that down because that's just multiplying. But I know that a is minus 1. And I know that c is 2. And then it's just a case of shuffling stuff around. I think I've found out what my b is. We all happy with that value? Okay, so the original question I was getting a, just write this down again so we can see it, plus bx plus c. That was what I was aiming for, had earlier. So I can now stick my values in. A is minus 1, b was 2, and c was 2. So that's what I can get. Any comments on having that as a final answer? Can I tidy that up at all?
Difference of 2 squares to minus 18.
Yeah, it would have to be a minus sign for that, okay? How about this? Can I write this down using less ink?
Use a pencil.
Oh, smart answer, I like it, okay? Right.
1 over 1 minus x?
Yeah, if I times the top and the bottom by minus 1, so just as an aside, okay? If I've got this, If I times it by -1 over -1, I'm timesing it by 1, it's not changing anything. Then I have a 1 on the top, and here on the bottom, -1 times by -1 is 1, x times by -1 is -x. Sorry, you couldn't see that. Okay? So, I could just write that as 1 over 1 minus x. It's one less minus sign, it's just mathematically nicer. Okay? And what could I do over here? I could take the 2 out. Yeah, it's a factor. Okay? So, that's just a nicer way of writing it down. There was nothing wrong, though, with what I had done earlier. Okay, I think that's finished that one, so that's going to bring us on to the next bit.